Now let's talk about initial value problem. It is obvious process, right? We talked about the general solution, right? It was came from characteristic equation and it was the linear combination form of the two specific solutions, right? And now we should decide the coefficient C1 and C2 of the linear combination form, right? But like for this case, keep that in mind. For first order differential equation, we needed only one initial condition. It was enough, right? But for here, you need two initial conditions to like verify two different coefficient, right? It is obvious, right? So let's start, okay? Here we go. So look at the differential equation. Just breathe in and out. Calm down and look at the do the like classification of the differential equation, okay? It is second order linear differential equation with constant coefficient and it is homogeneous, right? Then definitely we're going to use the characteristic equation, okay? So let's start from there, okay? Here we go. Equation is r squared plus 5r plus 6 equals 0. Then it's really easy to factor this guy, right? R plus 2 and r plus 3 equals 0, okay? And we can say r is negative 2 and negative 3. Then we know the general solution form, right? Which is why t is equal to c1 times e to the minus 2t plus c2 times e to the minus 3t, right? And then we're going to use like your initial condition. Look at that. It is y0 is given and y prime 0 is given, right? So to use these initial conditions, and we need to find y prime, right? Here we go. Let me do that first, okay? Y prime t is equal to, keep that in mind. You have to use chain rule everywhere, okay? So C1 and negative 2, which is negative 2 C1 times e to the minus 2t. The second term, negative 3 is come out as the chain rule. Is negative 3 C2 times e to the minus 3t. That's it. Now we're going to use the initial condition, which is given the problem, okay? Since y0 equal to 0, and we're going to plug in 0 into yt, right? Then it is 0 equal to C1 plus C2. You know what I'm saying, right? Because e to the 0 is always equal to 1, right? That's why I like C1, C2, okay? And since y prime 0 equal to 1, and now we're going to plug in 0 into y prime that set and then set that equal to 1, right? And then 1 is equal to negative 2 c1 minus 3 c2, right? Because e to the 0 is still equal to 0, right? And now look at that. From this guy and this guy, and we can set up the system, right? Here we go. The system of C1 and C2, right? C1 plus C2 equals 0, and negative 2C1 minus negative 3C2 equal to 1 now, okay? And like it is a linear system, and there is like a two way to solve this system, right? Elimination or substitution, okay? Either way, it doesn't matter, okay? But like for this case, let me try to do the elimination. Okay, so let me multiply 2 for the first equation. Okay, no, times 2. Okay, then let me rewrite this system. Okay, 2c1 plus 2c2 equals 0. And the second one, I'm not going to do anything. And then add up. Then c1 will be gone. Okay, then you have only negative c2 equal to 1. Then I can say mass c2 is negative 1. Then when you plug it back into anywhere, then you can easily find your c1 must be equal to 1 because c1 plus c2 equals 0, right? And this is the way to find c1, c2, okay? Then once you find c1, c2, then we have to update your general solution as the real solution with like initial condition, right? Here we go. So your solution yt is equal to c1 is 1, 1 times e to the minus 2t, and c2 is negative 1, and negative e to the minus 2t. That is your solution, okay?